enthalpy of reaction or heat of reaction. Enthalpy of reaction or heat of reaction. Have you heard about this term? No? Okay. Now, as the name suggests, enthalpy of reaction. So, what do you conclude? It is the enthalpy change during a reaction. Okay? So, if you forget the definition, if you forget the proper definition, you can still make the definition. Now, the proper definition is that the enthalpy of a reaction is defined as the enthalpy change accompanying the chemical reaction when the molar quantities of the reactants and products are the same as indicated in the chemical equation. It is also known as heat of reaction. It is represented by delta RH. R represents the reaction. So delta RH. Okay. Now enthalpy of reaction depends upon the various factors. Okay. So let us discuss the factors. Let us discuss the factors on which enthalpy of reaction depend. Number one is the physical state of a reactants and products. Well, the value of delta RH depends upon the physical state of the products. Okay. For example, hydrogen and oxygen combine to give water. Now, if water is formed in the liquid state, then more energy is released. On the other hand, if water is formed in the gaseous state, then less amount of heat is released. Okay, so it depends upon the physical state of the reactant and the product. Then the second factor is the quantities of the reactant. You know, the amount of heat evolved or absorbed depends upon the amount of the reactants, isn't it? Now, if you burn 1 gram of coal, the amount of heat produced will be different. But if you burn 1 kg of coal, then the amount of heat produced will certainly be more. So, it depends upon the enthalpy of reaction depends upon the quantity. Then third is the allotropic modification. You know, for different allotropic forms of the substance, different amount of heat is evolved or absorbed. For example, if you burn graphite, C graphite, you can see the reaction C graphite plus O2 gas gives CO2 gas. Here delta H is equal to minus 393.5 kilojoule. If you take C diamond, carbon diamond, and then it burns in presence of oxygen O2 to give CO2, delta H is 395.4. So what do you see? You can see that the amount of heat released when the diamond is burned is more than that of graphite. Then the fourth factor is the temperature. The value of delta H also depends upon the temperature at which reactants and products are considered. Let us consider the reaction H2 plus Cl2 give 2HCl. You know, the value of delta H at 298 Kelvin and at 348 Kelvin are minus 184.6 kilojoule and minus 184.8 kilojoule respectively. So you can see the same reaction is taking place. All the reactants and products are also the same, but the temperature, when you change the temperature, the amount of heat evolved or absorbed will be different. Then the fifth condition is the conditions of constant pressure or constant volume. The enthalpy of reaction depends upon the conditions of constant volume or constant pressure at a given temperature. So these are the various factors which affect the enthalpy of reaction. Now, standard enthalpy of reaction. This is another term, the standard enthalpy of reaction. This is delta RH naught. Well, you have just understood that the enthalpy of reaction depends upon various factors. Okay. Therefore, for the sake of comparison, the value of delta H for different reactions are expressed at their standard state conditions. Now, what is standard state? In thermodynamics, the standard state of a substance is its most stable state at 1 bar pressure and 298 Kelvin. Please remember this point. This is very important. The standard state in thermodynamics of a substance is its most stable state at 1 bar pressure and 298 Kelvin. Now, according to IUPAC recommendations, the enthalpy change at the standard state conditions is called standard enthalpy of the reaction, and it is denoted by delta RH. Then this is this sign. Okay, this superscript, this represents a standard state. Okay. Now you must understand that unless otherwise mentioned, the delta H values are the standard enthalpy change of the reaction. Okay. So you have understood what is enthalpy of reaction, what is a standard enthalpy of reaction. You have understood that the enthalpy of reaction depends upon so many factors. Therefore, we have to fix the conditions. And when we fix the condition of a standard state, then it becomes a standard enthalpy of reaction. Now let us discuss another term, molar enthalpy of formation, or simply enthalpy of formation. Molar enthalpy of formation, delta FH. Molar enthalpy of formation. Now this is also enthalpy change, but enthalpy change when 1 mole of a substance is formed. So how will you define? It is the enthalpy change accompanying the formation of 1 mole of a compound from its constituent elements. Okay, very simple to remember. Molar enthalpy of formation means enthalpy change when 1 mole of a compound is formed from its constituent elements. It is represented by delta FH. Now let us consider example. You know the enthalpy of formation of carbon dioxide is minus 393.5. So we can say that C solid plus O2 gas, when they combine together to form 1 mole of carbon dioxide gas, then delta H is equal to minus 393.5. This delta H is delta FH, enthalpy of formation of carbon dioxide. Similarly, in case of ethyl alcohol, you can see 2C solid plus 3H2 gas plus half O2 gas. This gives C2H5OH liquid. Now here delta H is equal to minus 277.0 kilojoule. Okay. Now this minus 277.0 kilojoule is the enthalpy of formation of ethyl alcohol. Why? Because in this case 1 mole of ethyl alcohol has been formed. Now when all these species of the chemical reactions are in their standard state, then the enthalpy of formation is called standard molar enthalpy of formation. Okay, standard molar enthalpy of formation. The standard molar enthalpy of formation is denoted by delta FH naught. How will you define a standard molar enthalpy of formation? Just like molar enthalpy of formation, the only thing is that we have to fix the standard condition. So the standard molar enthalpy of formation of a compound is defined as the enthalpy change accompanying the formation of 1 mole of a compound from its constituent elements all the substance being in their standard states, that is 1 bar pressure and 298 Kelvin. Now please note the following points. Number 1, standard molar enthalpy of formation of the substance is also called standard enthalpy, and it can also be represented by H naught. Second thing, by convention, standard molar enthalpies of free elements are taken to be 0. And third part, the standard state of elements refer to the pure element in its most stable form at 298 Kelvin and 1 bar pressure. For example, the standard state of carbon, oxygen, sulfur, mercury, iodine, bromine, etc. are C, graphite, O, O2 gas, S8 rhombic, I2 solid, Br2 liquid, etc. Now the values of a standard molar enthalpy of formation for some substances are given here in the table. Okay, you don't have to mug up this table. The values given in the table will be used to calculate, to solve the numerical problems. Okay. Now, what is the importance of standard molar enthalpies of formation? The knowledge of standard molar enthalpies of various substances can help us to calculate the standard enthalpy change of any reaction. Okay, so if you know the standard molar enthalpy of formation of the reactants and the products, then a standard molar enthalpy of reaction can be calculated, and vice versa. If you know the standard molar enthalpy of formation of the reactants and the products, but one reactant or product is unknown and the standard enthalpy of reaction is known, then the standard enthalpy of formation of that reactant or product can be calculated. Now, what is the formula? Very simple formula. This formula you must have to remember. You know, standard enthalpy of reaction is equal to sum of standard molar enthalpies of formation of products minus sum of standard molar enthalpies of formation of reactants. Okay, so it is represented by delta RH. This is equal to summation of delta FH, standard enthalpy of formation of products, summation of standard enthalpy of formation of products minus summation of standard enthalpy of formation of reactants. Okay, this is the formula. Now, if we have the reaction, suppose AA plus BB, this gives say LL plus MM, then delta RH naught is equal to summation of what? Delta FH naught of products minus summation of enthalpy of delta FH naught of reactant. So this is going to be L times delta FH naught of L plus M times of delta FH naught for M minus A times of delta FH naught of A plus B times delta FH naught of B. So this will give you the standard enthalpy of reaction.